Hello, Algebra 2 students! So here we are, focus and directrix translated form today. So you know how the last couple days we've been taking it kind of easy and having that vertex at 0, 0? Today that changes. So what's this going to look like and how are we going to go about this? Well, remember we've been talking about x squared equals 4py, y squared equals 4px as our standard form for focus and directrix. Remember that when the x is squared, this is going to indicate that we have a parabola that goes up or down. And when the y is squared, we have a parabola that goes right or left. Okay, and that p-value tells us how far away that focus is. So today we're going to take that vertex that's been at the origin, so 0, 0 was our normal location, and now we're going to shift that vertex spot over, up, down, wherever it needs to be. So your general forms are going to change a little bit. So notice we have y minus k squared equals 4p x minus h squared. So again, we still want that 4p thing to be happening, but what's going to happen is we have some parentheses here that will help us figure out our vertex to start. And again, notice who's squared. Sometimes it's the x, sometimes it's the y, and that's a big piece in our puzzle, okay? So let's just get going on those notes that you picked up. This is example 1. We need to find the vertex, focus, directrix, axis, symmetry, domain, range, all the key features of this parabola. So what we see here is we have x plus 2 squared equals negative 4, y minus 1. So if we were going to take a look at this and try to figure out what was happening, the first thing I'd like you to notice is that the x is in fact squared. It's the x who is squared, so we know that this parabola is going to either go up or down. That's our first indication. Now, how do we know if it goes up or down? Remember, that's our 4p thing that's happening over there. That tells me if he's going to go up or down. So because it's negative, I know my parabola right off the bat is going to go downwards. Okay? And then we again can figure out the p-value and all of those things. But remember, I said the difference between what we were doing previously and what's new today is that our vertex point has moved. So it's not located at 0, 0 anymore. Well, where in the world is it then? Well, if we use our knowledge of shifting and transformations here and our memory back, remember that inside parentheses will tell me how things are moving. Now, when they're in the parentheses like this, we're going to think about them as their opposite. So I see x plus 2. I should be thinking that the x value is really negative 2. So I know negative 2 is my x value. Looking over here at the y, I need to do the same thing there. I need to be thinking about the y shifting. Well, this says y minus 1. Think about the opposite. The y value is going to be a positive 1. So this is my vertex point. My starting value comes from looking in those parentheses. There's my vertex. Okay, that comes from what's inside those parentheses. So I now know my vertex point is already at negative 2, 1. I can go ahead and plot that on my graph. This is my vertex. Now, we also know the parabola wraps around this point called the focus. Now, the focus point is found by figuring out 4 times p and figuring out that p-value. This guy right here, the negative 4, we need to still think about it as being 4 times some p thing. And instead of there being just a y after it, you see how my y has kind of changed a little bit, but that's okay. I still need to figure out what that 4p thing is going to be. So 4 times negative 1 would have been the same as the negative 4 in the problem. So my p is negative 1. Negative 1 tells me that my focus is negative 1 units or negative 1 away from my vertex point. So knowing that this thing goes down and I know I have to draw my focus 1 unit away, I have to go down 1 for my focus point. So there's my focus dot. So my focus is at negative 2, 0. So far, so good. Now let's take a look at what else we can figure out from this equation, or what else we remember. To draw the rest of the parabola, we need to figure out the focal width. This is telling me that my width needs to be 4. So on either side of the focus, I need to go over 2 to have a total width of 4. So if I connect now my vertex to the 2 side points I drew, you can see the parabola wraps around the focus point. Now the directrix line, again, sometimes we forget to draw that in. He is evenly spaced. If the focus is 1 unit away from the vertex, the directrix line is also 1 unit away from the vertex point. So now we can go ahead and complete the rest of our key features here. So the directrix we have going through y equals 2. The axis of symmetry, if I were to fold this guy in half, I would fold him in half right here through where x equals -2. Now my domain value, this is an up and down parabola, so my domain is all real numbers, any x value. My range is a little different, y values. Let's look at the y values. Look, it's like the highest y value we would ever have. The maximum height of my parabola there is 1. And all my y values stay less than or equal to 1. So those are the key features of this first parabola that you have in your notes. Let's look at another one. This is y minus 1 squared equals -4 x plus 5. So again, first thing you maybe want to think about is which way is this parabola going? It's a y squared, so I know this parabola is either going to go left or right. Because I see a negative right here, this tells me that my parabola is going to go to the left. So I already know my parabola is going to go this direction like that. Now I just need to figure out where to put it. So I need to find that vertex. Now notice that this one's written a little backwards because the y squared comes first, but my vertex comes from the clues inside these parentheses. I'm going to start with the x clue first. This is telling me that my x coordinate is -5 on my vertex. My y coordinate is +1. Just because the y comes first in the equation doesn't mean we put the y first in the coordinate, okay, or in the point. So we're going to go ahead and list that as our vertex and plot that on the graph to remind ourselves what that looks like. So -5, 1 would be right here. Here's my vertex point. And we know this parabola is going to go to the left. Now we just need to figure out where that focus dot is. So again, I see a -4 right there. That is 4 times something, the p. The p must also be -1 again this time. So I need to go -1 units, or 1 to the left essentially, away from my vertex for that focus dot. So I'm going to go ahead and plot him right here. There's the focus. And now I need to figure out how wide to make this parabola. It needs to have a width of 4. So I'm going to count up to, down to, connect, wrap it around the focus. There we go, parabola going to the left. Okay, and I think I'll just go ahead and draw in my directrix line right away while I'm doing this. Evenly spaced away, 1 unit away from vertex, just like the focus. And now we should be able to complete all the missing pieces here. So the focus is at -6, 1. The directrix looks like it goes to the x-axis at -4, so I'd say x equals -4. The axis of symmetry, if I fold him in half, right here, through where y equals 1, so we'll say y equals 1 for axis of symmetry. And then the domain and range, remember, sideways parabola here, so the range is all y values, or all y values, all reals, okay? And the domain is, let's talk about the x, okay? Domain is always about the x. What's happening with the x values? It looks like the x value, the maximum here is -5. That parabola doesn't go any further to the right than -5. So I would say my x values are staying less than or equal to -5. So, example 2. Now let's take a look at that third example you have in your notes. Y plus 2 squared equals 16x. Again, your first task, decide which way this thing is going to go. So I see y squared. I know it goes left or right. I see +16 there. I know it's going to go to the right. So first thing you want to identify is just the general look of what that parabola is going to do. He's going to go to the right like that. Now I just need to figure out where to put him. So let's get that vertex. Now the vertex has an x part and a y part. You see this equation starts with the y part. Taking that clue, we know that the y is -2. Now what about the x? Usually there's a parenthesis there with the x and like something's being added or subtracted away from it. Here I don't see anything. That's because it's a 0. So our vertex is at 0, -2. Starting spot, vertex, 0, -2, labeling with a V, there he is. And we know he's going to go to the right. So I just need to get that focus point now, and I can wrap that parabola around him. So the focus point comes from thinking about that 16 as 4 times some p. What p goes in there? What p-value? 4. So the p-value is 4. That means my focus point is 4 units away. So we can go ahead and count 4 units away to the right. 1, 2, 3, 4. There's the focus. Now my parabola has to wrap around this focus. Think about how wide. The total focal width here needs to be 16. So that means it needs to be 8 wide on either side in order to make 16. So I'm just going to go ahead and count up 8 from the focus. 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Nice. Fits right on the graph. Okay, and then we will wrap that parabola around the focus. Nice. Draw in the directrix line. 4 units away from the focus. Got to go 4 on the other side. There's the directrix. Okay, evenly spaced. And now we should have all the features we need to fill in. So where did we put our focus point? We put our focus point at 4, -2. Where did we put our directrix line? It's going through the x-axis at -4. The axis of symmetry, where would I fold him in half? Right here, through the vertex and the focus, where the y is -2, through the y-axis at -2. Domain and range, sideways parabola, all y values are accounted for. There's positive y values, there's negative y values. All real numbers for the y values, for the range. The domain is a description of the x's. What are the x's doing? Looks like the x's are staying positive, huh? They're not going into any negative territory. So I would say x is greater than or equal to 0. So third example here, all 3 involving moving of that vertex before you get started on the focus and directrix spots, okay? So be thinking about where that vertex point is now and how you can carry over what you've learned into making those good parabola graphs. Thank you for taking good notes.